Okay, this is a quick video on the graph for the stimulus question on Wednesday about furnaces. What we have is blacksmith working on some steel, and what temperature does the steel start at? Well, if you're actually quite sensible, your temperature should start at about room temperature, 20 degrees C, roughly. That's your starting temperature. When you put it into the furnace, it's going to rise to about 400 degrees C. And that takes quite a long time for it to work. So it will rise quite quickly to start with, and then as it gets closer and closer to 460, it actually all going to become more difficult to put the extra heat in, and gradually it gets towards the top. And around 460, there's a transition change. So this could level off for a short time, and then it changes. But to about 460, he's got bright red steel, so he takes it out and he plunges it into some water. Now, I'm going to assume the water starts off quite cold. He puts it in, and the temperature is going to crash down, and it will cool very quickly. We're going to assume there's not that much water, so it will actually heat up. But the temperature of the steel crashes down, and then gets somewhere around the temperature of the water. And then he's got to go through another cycle. He's got to heat it, quench it. This is for making laminated steel, the sort of thing that goes into good knives. So when you break it, a small laminate comes off, not breaking the whole knife in one go. So again, cycle 2, it comes to the bottom, he's quenched it quickly, and it warms up again. And it will follow a very similar profile to this one. It should be pretty much the same. And it comes over the top and drops down. And this will keep it going for the 6 cycles we were talking about. And it will do pretty much the same. The one change is when you do the extension, you may realise this bottom temperature may not quite get reached, and it may not quite get down to this temperature all the time. And then we're going up again. So we get this sawtooth pattern. Due to technical reasons, it does slow up towards the top. But the important thing is the water quenches it quickly, so the temperature falls very quickly. What happens to the water temperature? Well, this is the extension bit. It says it starts off at 4 degrees C. And the point is, water can only reach the temperature of about 100 degrees C under normal circumstances. It cannot go any higher, because it will suddenly boil and turn into steam. It's no longer doing the cooling effect. So what happens with our water temperature? Well, during this first cycle, and this is the first thing that catches people out, it's just sitting there. So it stays very stable. Stays about 4 degrees. It might get slightly warmer towards the room temperature, but it won't get up to our 20 degrees. Here's our 20 degrees. Now the steel gets put into it, and the water temperature rises quite quickly. And whilst it's in there, we're starting to get more and more steam. Steam's going up, and eventually we get to a point where that's it. That's about the limit of the temperature. Take the steel out, and the temperature starts cooling again. And assuming this is long enough that the water's going to cool quite a lot, what will happen is it will start falling down. But there's a limit. The temperature it can fall down to is only about the 22 degrees of the room. It can't fall below this. There's no way for us to get energy moves from hot things to cold things. So you can't get the energy to come out of the hot water into the cold water. So it levels off. We then plunge it again, it rises quickly, we blow off a load of steam, and this could rise even quicker because we've got less water to cool me. And it drops round, and what you might find is the water temperature may not quite return back to here anymore. There's less temperature for it to be absorbed, there's less for it to get rid of. That temperature is now not going into the same mass. So this bottom bit could, after that first jump, actually rise slowly. Okay, quite complex question. This is what it's there for. It's there to make you think. and then do you understand enough about the graphs? Okay, video complete. Stop it.